Now we're going to move on to what's called differentiation by rule. So let's recap now. We did differentiation from first principles where we have our long method of f of x plus h minus fx over h, and the limit as h tends to 0. Now it would be quite long and kind of laborious for us to do that for every single question that we do. So differentiation by rule gets us the same answer in a quicker way. So sometimes you might be asked to do it using first principles. You have to use your formula then. But on the whole, you can use this quick method unless it specifically says in the question, differentiation from first principles. So let's go back now again and say, what other words do they use, right, that mean the same thing as differentiation? So they might say differentiate, which is fine. They might say find the derivative. That's the same thing. You do exactly the same thing. The question might say f of x is equal to something. Find f dash x. That means differentiate. You might be told y is equal to something. Find dy dx. That means the same thing. Differentiate. You might be asked to find the slope, and we know that differentiation is the slope of the tangent to the curve at a particular point. So it means differentiate. We might find the gradient. Gradient means slope. Find the rate of change. We came across that in the first part of the chapter. So they're all, speed was another one, do you remember? So they're all stuff that mean exactly the same thing, differentiate. And this is what we'll do to differentiate the quick way. So let's say this is y is equal to x squared, and you're asked to find dy dx. So that means the rate of change of y with respect to x. So here, if that's a 1, it's 1x to the power 5. The rule is, bring down your 5 and multiply it by 1. So 5 ones are 5. X and reduce the power by 1. So reduce it by 1, you get 4. And that's your derivative, 5x to the power 4. So this is the slope function for this curve. This one, same method again. dy dx gives me what? Bring down your power multiplied by the coefficient. So 2 by minus 3 minus 6x. Reduce the power by 1. So 2 minus 1 is 1. And that's your derivative. Moving along here, right? Look at these ones here. If you're asked to find dy dx, again, bring down your power. So that's 12x. Reduce the power by 1. So it becomes 2. Bring down your power. Minus 6x. Reduce the power by 1, it becomes 1. Now this is x to the power 1. So bring down your power. 7 ones are 7. X to the power of, reduce the power by 1, 0. If we want this one, is really x to the power 0 already. Bring down your power. So 0 by 6 is 0. So any constant value differentiates to be 0. Right? Finishing this off, 12x squared minus 6x to the power 1. X to the power 0 is 1. So that's just 7. And we don't have to write naught. So just to recap, if you're differentiating an x number, it's just the coefficient is the derivative. If you're differentiating a constant, it disappears, it's 0. Because we know that if we have a constant line, like here, y is equal to 3. The derivative of that, the slope of that line is 0. Right? It's a constant value. So any constant will give you 0. This one will be the same. So dy dx, differentiate. 5 4s are 20. Reduce the power by 1. Minus 3 7s are 21x. Reduce the power by 1. Minus 2 2s are 4x. Reduce the power by 1. Minus 7x is just minus 7. 9 differentiates to be 0. I don't need to write it down. Okay, so any x value, you just take the coefficient. Now, what about this one? Again, find dy dx. Now, this one needs to be changed because everything has to be running along the same line. So this is throwing it out a little bit. They have to be running along the same line before you can differentiate it. So we would have to tidy this one up. So this would really become, right, the first part is fine. So y is equal to 4x cubed minus 10x squared. But it has to be running along the same line. So I have to bring this up. So that's 7x to the power of negative 1 when I bring it up. This has to come up and it's now running along the same line and I can differentiate it. So to find the derivative, bring down your power. So 4 3s are 12x, reduce the power by 1 squared. Minus 20x, reduce the power by 1, you get 1. Minus 1 by 7, minus 7x, reduce the power by 1. So minus 1 is minus 2. Okay, tidy it up. 12x squared minus 20x. Now, this one here, right, you leave the number alone. So you leave the constant number, which is 7. Now, this is really over 1. So if I flip it, it's 1 over x squared, making it positive. So it's 12x squared minus 20x minus 7 over x squared. The 7 will never go below. You leave the number alone. You never move the number. It's just the x that's moved. So this is dy dx, differentiated it, okay, in its simplest form. I'll keep going, right? This one again needs to be rearranged. So this has to come up. The 7 stays where it is. So y is equal to 4x cubed, 7x to the power of negative 2, plus 5x minus 10. Now differentiate it. So when you differentiate this, you will get dy dx, right? So bring down your power. 12x, reduce the power by 1. Minus 2 by 7, minus 14x, reduce the power by 1. It's minus 3. 5x differentiates to be 5. Minus 10 differentiates to be 0. So I tidy this up. What will I get? 12x squared. Remember, the 14 stays where it is. Minus 14. This is over 1. Bring it under the line and it's x cubed. Okay? And then plus 5. So that's your simplified answer. Okay? Watching this, the number always stays where it is. Another one, say. Right? So this time again, we can't differentiate this the way it is at the moment. These have to be simplified. Bring them up. Now again, you leave the numbers where they are. So f of x equals 5x cubed plus 3 over 2. You do not move the 2. It's only the x that you move. X to the power of negative 2. Then plus 4 stays the same. X to the power of 1 comes up and it's to the power of minus 1. Plus 2. Now I differentiate. So this time I'm finding f dash x, the derivative. So bring down your power. 15x, reduce the power by 1. Right? 3 over 2 x. Now when you have this one, it's minus 2 by 3 over 2. So that's minus 6 over 2. Minus 3 by 2 is minus 6 over 2. X. Reduce the power by 1. Minus 3. Bring down your power. Minus 4x. Reduce the power by 1. Minus 2. Differentiate 2 and it becomes 0. So we tidy it up. What do I get? 15x squared is fine. Right? This is over 1. It has to go under the line. 6 divided by 2 is 3. Right? You have 1 over x cubed. Isn't it? So it's 3 by 1 over x cubed. This is the same. Minus 4 stays as it is. This is over 1 multiplied by 1 over x squared. So now I get 15x squared minus 3 over x cubed minus 4 over x squared. And this is f dash x, the slope function, or the derivative. Alright, so I'll keep going and do another few. This one here, f of x is equal to 6 root x. Right, I have to try and get that root x to be more simplified. So root x is the same as x to the power of a half. Right, cubed root of x is x to the power of a third and so on. So the square root is always x to the power of a half. So find the derivative, f dash x. Bring down your power. 1/2 multiplied by 6 is 3. X. Reduce the power by 1. So what's that? A half minus 1 is minus a half. Right? I want to make that positive. Leave the number 3 alone. This is over 1. Flip it and it's 1 over x to the power of positive a half. The minus comes down and becomes positive. And that's equal to 3 1s are 3. x to the power of a half is the same as root x, or leave it as x to the power of a half. But that's your slope, or your derivative, or f dash x. Same here, right? F of x is equal to 6 over the cubed root of x is x to the power of 1/3, isn't it? Bring that up before you differentiate. So f of x is equal to 6x to the power of negative 1/3, right? Differentiate, minus 1/3 by 6. So f dash x gives me minus 1/3 by 6 is minus 6 over 3, which is minus 2. X, reduce the power by 1, minus 1 and 1/3, or minus 4 over 3. Okay? You want to make that positive. Flip this. Leave this alone though, right? So f dash x equals minus 6 divided by 3 is 2. This is flipped, 1 over x to the power of 4 over 3. So your answer is 2 over x to the power of 4 over 3. And that's your derivative, or your slope function again. Okay, I hope they're clear now. So that's number 9. I have 2 more to go through with you. Right, here, again, f of x is equal to 2 over root 4x minus 1 over x to the power of 4 plus 5. So f of x, we have to tidy it up first. This is the same as 2 over x to the power of a half minus, bring this up, x to the power of minus 4 plus 5. Bring this up. I haven't done any differentiating yet. 2 stays as it is. X to the power of negative a half. X to the power of negative 4 plus 5. Now I can differentiate. So f dash x equals minus a half by 2 is minus 1. X, reduce the power by 1. Minus 1 and a half, which is the same as minus 3 over 2. Bring down your power. Minus 4 by minus 1 plus 4x. Reduce the power by 1, minus 5. Differentiate a constant and you get 0. Okay, so tidying that up, the minus 1 stays as it is. Flip this and it's 1 over x to the power of 3 over 2. The 4 stays where it is, and this is 1 over x to the power of 5. Giving me minus 1 over x to the power of 3 over 2 and 4 over x to the power of 5 as my answer. Okay, right, we'll go on. This one again, this is the same as 2x to the power of a half. 2 stays as it is. The x to the power of a half goes up. So f of x is equal to 3x to the power of minus 2. The half stays where it is. The x goes up. So x to the power of negative 2. The half stays where it is. Right? Differentiate f dash x. What do I get? Minus 6x. Reduce the power by 1. Minus 3. Minus a half by a half. Minus a quarter x. Reduce the power by 1. So minus 1 and a half, or minus 3 over 2. Again, tidy it up. So minus 6, 1 over x cubed. Flip this. Minus a quarter, 1 over x to the power 3 over 2. Your numbers stay the same. So giving me minus 6 over x cubed. Minus 1 over 4 by x to the power of 3 over 2. And remember, that's the slope. If I wanted to get an accurate value for the slope, I would be given a point, maybe at the point 1, 2, right? If it was at the point 1, 2, I'd sub in everywhere I see an x, put in 1, okay? And it would give me a numerical value for the slope. Like I'm asked here, find the slope of the tangent to the curve. So to get my slope, differentiate, dy dx. Slope means differentiate. So this is y. So dy dx is 6x plus 4. Differentiate 5 and it gives you 0. So this is my slope function, right? I'm given the point at the point 1, 2. X is 1, y is 2. So everywhere I see an x, I put in 1 and I get 10. So this is the slope, a value for the slope of the tangent to the curve at the particular point. This is my curve. How do you find the equation of the tangent? Y minus y1, m into x minus x1. Right, 1 second, I'll have to answer that now. I'll leave it go. So I have y minus 2 is 10 into x minus 1. So y minus 2 is 10x minus 10. 10x minus y minus 10 plus 2 is 0. So that's 10x minus y minus 8 is 0. That's the equation of the tangent line. There's one more like that. Here again, find the point on the curve when the slope is 3. So the slope is equal to 3. So slope means dy dx is equal to 3. dy dx is 4x minus 1. Okay, 4, differentiate that and you get 0. It's equal to 3. So 4x is 3 plus 1, which is 4. X is 1. So x is 1. Find the y part because you're asked to find the point. Go back and find the y part. Y is 2x squared minus 1x minus 4. So y is 2 by 1 squared, 1 by 1 minus 4. Y is equal to 2 minus 1 is 1 minus 4 is minus 3. So that's 1 minus 3. So if you had your curve, it's a quadratic, you're looking for the slope of the tangent line, right? The slope we were told was 3. You're looking for the point. The point is 1 minus 3. So the slope of the tangent at the point 1 minus 3 is 3. You've worked backwards. All right, there's a good bit there now. What you could do now in those, when you go to your books on page 277, your book 4s, you could do question 1 to 4 to get yourself started on it. Right? Okay. Thanks.